Okay, so we're going to fill in these definitions. So the first definition here is for a ratio. Now, a ratio, probably the simplest way to say it's just a fraction. Okay? A ratio is a fraction, but we'll write a more formal definition. So we're going to write a comparison of two quantities using division. Oop. Hold on, let me squeeze this in here. All right. So that's supposed to say a comparison of two quantities using division. But it's just a fraction. All right? Well, then a proportion, the next one, that's just going to be two equal fractions. So a proportion is just going to be two equal ratios. And then it says cross multiply. So what we're going to say there is that if you have a proportion, then the cross products are equal. So we'll put proportions can't write today, hold on. So proportions have equal cross products. So proportions have equal cross products. And then a rate. A rate is just a ratio with two different units. So it's just a fraction with two different units of measure. So a rate is a ratio with two different units. And then the last one, a unit rate. Well, that's just a rate where the denominator is 1. Doesn't look like a 1. You guys good? Now I'm going to go back in here and I'm going to fill in an example of each of these things. So the first one was ratio. Again, that's just a fraction. But a lot of times you'll see it written like, sometimes they'll write it like 3 to 5. That would be a ratio of 3 to 5. Or sometimes they'll write it 3 and then a colon and then 5. Or probably the simplest way to write it is just 3 over 5. So those all mean the same thing. But it's important to note that when you have this word 2 in here, if it says 3 to 5, the 3 goes in the numerator, and then the 5, that would go in the denominator when you write it in fraction form. All right, then the next one says the proportion is 2 equal ratios. Well, that's just 2 equal fractions. So for example, if I wrote something like 2/3 and I don't know, 10 over 15. Is that true?
Yes.
Yeah. So the one fraction is just a reduced form of the other one. 2/3 is the same as 10 over 15. So that's the proportion. And then the next one, it says proportions have equal cross products. So let's use that same example. So if I have 2/3 equals 10 over 15, what do I get if I multiply these two together? What's 2 times 15?
30.
All right, so I got 2 times 15 would have to equal the other cross product. So what's 3 times 10? 30. So what this thing says then is it just says 30 equals 30, right? That checks. So that's a property of proportions, okay? If you got 2 equal fractions, their cross products are equal. And then that'll help us solve some problems. That'll help us solve some equations, that property. Okay, and then an example of a rate. A rate could be something like, I don't know, what do we want? Maybe like 150 miles. 150 miles over 3 hours. Do you see that I got 2 different units? The numerator is in miles and the denominator is in hours. It's still a ratio, it's still a fraction, right? But the units are different. So that's an example of a rate. And then if you want to, for the last one, if you want to make a unit rate, all you have to do is divide. So if you use that same example, if I have 150 miles over 3 hours, well, if I go ahead and divide these, so I want to divide. Well, what do I get if I divide 150 by 3?
50 miles over 1 hour.
Yeah. 150 divided by 3, that's 50, right? So that's going to give me 50 miles. I can't make an M. That's going to give me 50 miles over 1 hour. Well, that's what I said a unit rate was. I said a unit rate is a rate where the denominator is a 1. So you can see here I have a denominator of 1 now, right? And then a more common way to write that would be, you would write 50 miles per hour. Like that. You guys know that you can always put a 1 under that 50, right? 50 over 1 is the same thing as 50. Yeah, so that would be your unit rate. In fact, that would be your speed, right? If you traveled 150 miles in 3 hours, if you change that into your unit rate, that would be your speed, 50 miles per hour. You guys good with all that stuff? So that's all the examples of that. Now we got to solve problems. All right, so here we go. All right, so what do we got here? It says the ratio of the number of bones in the skull to the ear is 11 to 3. So 11 to 3, you can see right here you have let's see, you have human skull to the ear, right? Well, that means the 11, that goes with the skull, and then the 3, that goes with the ear. So what you would write then is you'd say 11 over 3. And then you got to remember this numerator, that's skull. So that's skull bones. And the denominator is ear bones. Well, then when you set up your other fraction to get your proportion, we're going to solve this using a proportion. We got to make sure the numerator is skull bones and the denominator is ear bones again. So this has to be skull bones on top. And that has to be ear bones on the bottom. So what did they give us here? What is that? Yeah, it's 22 bones in the skull. So where does that go, on the top or the bottom? Yeah, it goes on the top. And then we're trying to solve for how many bones are there in the ear, right? It says how many bones are in the ear. So that's our x. Then we're just going to solve that thing. And now we're going to use that property that if you got two equal fractions, if you have a proportion, then you can set the cross products equal, right? So the cross products have to be equal. So we're just going to do 11 times x. So what's that?
11x.
That's 11x equals, and we're going to do the other cross product. That's 3 times 22. 66, good. And then we're just going to divide both sides by 11. The 11s are going to cancel, and we're going to get x equals 6. And then usually on these, since they're word problems, you got to put the units on there. So in this case, the x was the number of ear bones, right? So the answer is x equals 6 ear bones. Can you guys see that? Okay, I'm kind of writing small. You all right? Okay. All right, next one. Same idea on the next one. We're going to use a proportion to solve it. So it says the ratio of gains won to lost. Okay? So again, it's 1 to lost. It's 3 to 2. So that means the 3 has to go with the gains won, and then the 2 goes with the gains lost. So again, do you guys remember that? So the first number here, like this right here, the 3, that goes with the word before the word 2. Okay, so we're just going to put this as 3. So this is just going to be 1 over lost, right? So we're going to say, we do not want that. we're going to say 1 over lost. So the ratio is 3-2. And then the 18 games, is that won or lost? Yeah. So right here it says they won 18 games. So does that go in the numerator or the denominator? What's that? Yeah. So that's going to be an 18. And then it says, how many games did they lose? So this part says, how many did they lose? So that's going to be your X. And again, you can see this is set up as this is games won in the numerator. And this is the number of games lost in the denominator. So you just got to be consistent. Okay, if you set up the one ratio as 1 over lost, you got to set up the other ratio also as 1 over lost. And then you're just going to use the cross products to solve it. So let me come over here. So this cross product, 3 times X. What's that? Thank you. 3X, that has to equal the other cross product, which is 2 times 18. So what's that? What's that? 2 times 18?
36.
Thank you. Then we're just going to divide both sides by 3. The 3's are going to cancel out and make a 1. And we get X equals 12. And that would be 12 what? Yeah, that's how many losses they have. So 12 games lost. And again, on these problems, we don't want to just write 12. We want to say 12 games lost. Same thing with the previous one. Up here, you just don't want to say X equals 6. You want to say that there's 6 ear bones. All right? You guys good so far? Yeah. Let's try this one. So this one, we're just looking for a unit rate. Okay? And it tells you that they want the unit rate in right here. It says flips per second. So we're going to want this thing to look like flips per second. Well, how many flips was there? 416 flips. And that was over how many seconds? 120. Now that right there, that's a rate, okay? But they don't want just the rate, they want the unit rate. Okay, they want this thing right here. So it says unit rate. So whenever you want the unit rate, you just got to divide that so that you get a 1 in the denominator. So what you need to do here is divide these out with your calculator. So you want to divide that.
20.8.
I don't know, let me grab my calculator too.
I'm sorry, I did it.
You get some weird decimal or something?
Yeah. 3 point something.
4.16 or 416 divided by 120.
3.46 would be like.
Okay.
Just the.
So we get 3.47, or I'll write it like this. I'll write 3.4 with the 6 is repeating, right?
Yeah.
3.46 flips. And that will be over 1 second, right? So you get 3.46 repeating over 1. All right, maybe I'll just round it off then. So it's approximately 3.5 flips per second. So you guys can see we have a denominator of 1, right? That's what you want. You want to divide that out, the 416 divided by 120. You want to divide it on your calculator so that you get a denominator of 1. So that's your unit rate. So that means he has about 3.5 flips every 1 second. All right, let's do number 4. Now number 4, that's a unit conversion problem. They're telling you that the cheetah can run at 60 miles per hour, and they want to know what would that speed be in feet per minute. So somehow we got to change the time unit, which was hours. We got to change that into minutes, and then we got to change the distance unit from miles into feet. So let me zoom in on this one a little bit. So here's what we're going to do. We're going to start out with 60 miles per hour. So we've got 60 miles over 1 hour. All right, so let's change from miles into feet first. Now, in order to do this, you need to know a conversion factor. You have miles on the top, and then you're going to want miles on the bottom so that the miles will cancel out. So then we're going to want feet on the top. So then does anybody happen to know how many feet are in a mile?
It's like 5,180.
That's close. What did you say again?
Is it like 5,180 or something?
I think it's 5,280. So you're really close.
I don't know. We had to learn it for science last year.
So this is 5,280. There's 5,280 feet in 1 mile. That's your conversion factor. So we've got our answer in feet now, but we also want to change the time unit from hours into, what do we got to get into? Minutes? Or seconds?
Minutes?
Minutes?
Seconds.
What does it say?
Easier.
Oh, they want it in feet per minute, right? All right. So then we got to get the hours to cancel out. So if we have hours on the bottom right here, our next conversion factor, we're going to need to put hours on the top so it'll cancel out. So it'll look like this. So we want hours on the top so that those will cancel. And then we want to come out in minutes. So then how many minutes are there in an hour? 60. So you got 60 minutes in 1 hour. So make sure you put those numbers in there so that they make sense, right? Again, we're trying to get the hours to cancel here. Guys, we're trying to get the hours to cancel out. So I put hours on top and minutes on the bottom. And then just make sure your conversion factor makes sense now when you read it. This says 1 hour is the same thing as 60 minutes, right?
Yeah.
Okay. So now the only units you have left, you have feet in the numerator, right? And you have minutes in the denominator. So that means your answer is going to come out in feet per minute. So your answer is going to be in feet per minute, which is what we wanted, right? All right, so then how do you do this? Well, I mean, you could do 60 divided by 1 times 5,280 divided by 1 times 1 divided by 60. That would be kind of the long way to do it. The easier way to do it is you just do 60 times 5,280 divided by 60. In other words, if these are both on the top, you multiply them. And then if this one's on the bottom, multiplying by 1 over 60 is the same thing as dividing by 60. So really you just multiply these two numbers together and then divide by that number. But in this case, in this one's kind of obvious because what happens to the 60s?
They cancel.
Yeah, they also cancel. That's normally not going to happen. It's just because they started this one right here with 60 miles per hour. All right, if that would have been a different speed right there, they would not have canceled out. But anyways, in this case, yeah, they'll cancel out. This one is going to cancel with that one. So the answer is just going to be 5,280 feet, right? And that's going to be in 1 minute. So again, you could write it like this then. So it's 5,280 feet per minute.
That made absolutely no sense.
All right. Let's get through the rest of these. So the next three, quiet guys. You guys ready? The next three are already set up. They're just proportions. We just got to solve them. So let's do these. So we're just going to do the cross products, right? We have two equal fractions. So we have our proportion, so we just do the cross products. So this cross product, 3m, is equal to that cross product. What's 9 times 5? 45. Then just divide both sides by 3. And you get m equals, what's 45 divided by 3?
15.
Good. Next one. Now the next one you need to be a little more careful, because when you do this cross product right there, you've actually got to set it up so that you distribute. So that would be 2 times the quantity y minus 3 in parentheses. That would equal the other cross product, which is 6 times 7.
42.
Yep, that's 42. Now in this one, you could divide both sides by 2 to cancel that 2 right there, because 42 is divisible by 2, right? But if it wasn't, if that was not an even number right here, you would want to do that, because then you would introduce fractions. So I'm going to go ahead and distribute. So I'm going to distribute that 2. So 2 times y is 2y. 2 times negative 3 is negative 6. And that equals 42. And then we add 6 on both sides. And we get 2y equals 48. And then we divide both sides by 2. So we have 2y equals 48. Divide both sides by whatever number's in front of that variable. Those cancel out, make a 1. We get y equals 24. All right? What's up? Yeah. Yeah, we've had lots of practice solving those equations, though. That's what we've been doing so far in chapter 2. Again, make sure when you distribute right there that is a positive 2 times a negative 3, so that's a negative 6 right there. All right, the next one, this is a little bit different. I don't think we've done one like this before. So this one, we got to do this cross product right here. What's a times a? Any number times itself would be, it'd be a what? A to the, how do you say that?
Wait, what was the answer to the last one?
A to the power.
Yeah, that would be a to the second power, right? A times a is a squared, or a to the second power. When you square something, that's the same thing as that thing times itself, right?
Wait, Mr. Sir,
What's up?
the answer to the last one is y equals 24?
Yeah.
Is that it?
Yeah.
Oh.
All right, then we set that equal to the other cross product. So the other cross product here is 2 times 8. That's 16. Now see if you can just do this in your head. What number could you put in there? What number squared equals 16?
4.
That's good. That's one solution. What's the other number times itself that equals 16?
Negative 4?
Yes, negative 4. Rachel, that's good.
Yeah.
So here's how I want you to do this. So whenever you have something like this, you want to get rid of the squared. So the opposite of squaring is to square root. All right? So the opposite of squaring is square rooting. So we got to get rid of that second power on that a. Now remember, when I do a square root, there's actually a little 2 in here, right? So what's the square root of a squared? Just a. But whenever we take the square root of both sides like this, whenever we do that, we've got to remember to put a little plus or minus over here on the right-hand side. So whenever we take the square root of both sides of an equation, again, if you guys are going to talk over there, you're going to get moved, okay? And it's going to be permanent this time. So whenever we take the square root of both sides, we put a plus or minus in there. Because we got to get 2 answers. One answer was positive 4, and the other one was negative 4. Does that make sense? If you look at this thing right here, if you put 4 in there, 4 times itself, 4 times 4, that would be 16. But if you put negative 4 in there, negative 4 squared would be negative 4 times negative 4. That would also be positive 16. That's why we have 2 answers here. A is 4 and A is negative 4. All right, the next one. So this is the last one, right? It's the last one for this section. All right, this one says they're building a house. The plans for the house, that's called the blueprint. The blueprint says that the scale, every 1 inch on the plan is the same thing as 3 feet in the actual house. Maybe I'll zoom in a little bit. All right, so that's your scale factor right there. So 1 inch on the paper is actually 3 feet in the real house. So then it's a ratio of 1 to 3 right here. Well, that means that we've got 1 inch on the plan is the same thing as 3 feet in the house. So again, this is that's from the blueprint. And this is in the actual house. Well, then just if we're consistent with the units, we can set up our other fraction or our other ratio. So this must also be inches over feet. So then the one they gave us here is this one. So where does that go, top or bottom? It's 6.5 what? Inches. So that's got to go on the top then. Well, that means our x then is going to go on the bottom. Does that make sense? Because it says right here, how long is the actual wall? So that would be the actual wall in the house. Like, how many feet long is that? So let's do our cross product here. So we're just going to do, 1 times x, that's just x. And then we're going to do 3 times 6.5. What's that, 19 and a half?
Yeah.
And again, you can see that answer for x is going to come out in feet. Okay, that's the length of the actual wall in the house. So that's going to be in feet. And then we're going to use the same scale factor for part B. In part B, we still got 1 inch in the plan is the same as 3 feet in the actual house. We set that equal to, and then this time we're given 12 feet. Well, again, the other fraction or the other ratio, that's also got to be in inches over feet. So where does the 12 go, on the top or the bottom? Yeah, it goes on the bottom because it's 12 feet. And then we're looking for x inches. So I kind of cut off the question here, but if you read it over here, if it's 12 feet in the real house, then they wanted to know, well, how long is the wall on the blueprint? So they want to know how many inches is the wall on the plan. So we'll do our cross products again. So we'll go this way. So we got 3 times x, so that's 3x equals, and then we'll go the other way. 1 times 12 is 12. Divide both sides by the number out in front of the variable. These will cancel out and make a 1. So we get x equals 4. And would that be inches or feet?
Inches.
Yeah, you can see right here, we're looking for x inches. So it's 4 inches on the diagram or the blueprint. So a 12-foot, let's see, a 12-foot wall in the house will be 4 inches on the plan. And I think that's it for that one. But I think I'm going to go right into the next section for you guys. The next section is nothing new. All we're going to do in the next section is we are going to still just set up proportions like this. And we're still going to use the cross products to solve them. So there's really nothing new in section 2.8. It's just a couple of other different kinds of examples. So let's look at that. So that was all that stuff. That was a lot. That's all the stuff for 2.7. So turn the page, and we'll look at 2.8. So 2.8 only has 4 examples. So hang in there with me. 2.8. It says in geometry, we are going to deal with similar figures. All right? So similar figures. The symbol for similar is this. If you see that symbol, it means the 2 figures are similar. And what similar means is the same shape but different size. So similar means the same shape but different size. And then we can go right into doing these examples. All right, now, they didn't draw these very well. This first one, these triangles are supposed to be the same shape, but different size. I don't think they got it quite right, but we'll go with it. So all you got to do on these is you just got to match up the corresponding sides, that's all. So what does the x correspond with in the big triangle? Yeah. That corresponds with the 14, right? And then what does 3 in the little one correspond with in the big one?
6.
The 6, yeah. Actually, I should do that like that. All right, so then all you got to decide when you go to set up your proportions for these is do you want to do big over little or little over big?
Little over big.
All right, you want to go little over big. So we're going to go... We're going to go small triangle over big triangle, or large, I guess I could say. All right, so we just got to make sure we're consistent like that. So we're going little over big. So x in the little one, what does that correspond with in the big one? 14, good. And that's going to be equal to, or proportional to, or in the same ratio as 3 in the little one, that corresponds with 6 in the big one, right? Does that make sense to you guys? That's all you got to do. As long as you're consistent. Again, we're doing small triangle lengths over big triangle lengths. All right, then we just solve that. So we're going to do our cross products. So we're going to do 6 times x equals 14 times 3. What's that, 42? And then we're going to divide both sides by 6, which is the number out in front of the variable. Those are going to cancel out and make a 1. And we get x equals 7, and the units are right here.
Centimeters.
Yep, centimeters. Now, do you see why I'm lumping this in with the other lesson? It's really the same thing, right? Let's do the same thing on number 2. So let's match up the corresponding sides again. So 7 in, or what is that, a 7? I can't even see.
This only works if you're using the same shape, right?
Yes, they got to be the same shape but different size. That's what it means to be similar. So I think that's a 7, isn't it?
Yeah.
All right, so that matches up with what?
The 7, it goes 5,
3.
The 5. And then the X matches up with what?
the 2.
The 2. Now, just to change it up on this one, let's do the big over the little this time. So we're going to do big over little. As long as we're consistent like that, it'll work fine. Now, these are quadrilaterals because they have 4 sides. So 7 in the big one, that corresponds with what in the little one?
5.
5. And then X in the big one corresponds with
The 2.
the 2. And then,
X equals 14.
yep. So we just do our cross product. So we got 5 times X equals 7 times 2, which is 14. Then we divide both sides by whatever number's in front of the variable. That cancels out, makes a 1. We get X equals, if you divide that on your calculator,
2.8.
yep, you'll get 2 4/5, which is 2.8. And then you look for the units here, would be what? Yep, that's inches. There we go, we got those done. All right, we got a couple to go. 2 more, right? All right, I'm going to try to blow this up so I got some room to draw here. So this says a flagpole casts a shadow 75 feet long, and at the same time, a 6-foot man casts a shadow that's 9 feet long. So let me try to draw you a picture of this. So what you have here is you have the sun. That's the sun. Okay? And then the sun's rays are coming down like this. And here's the flagpole here. So there's our flagpole. And then where's the shadow then? When you stand outside, where's your shadow?
It's on the ground.
It's on the ground. So your shadow's down here, right? So that's your shadow down there. And so then that is 75 feet, okay? But at the same time, there's a parallel, sun ray coming down over here. Like that. And then there's a guy standing here. I'm having trouble with my artwork here. So here's my guy. He's got one eyeball, it looks like. There you go. There's my guy. And his shadow's right here, right? So then he is 6 feet tall. And his shadow is 9 feet. Well, those are similar triangles, okay? They're the same shape but different sizes. And we're trying to find the height of the flagpole, which we'll call X. So what does the X correspond with?
The height of the flagpole.
The X corresponds with the 6, right? And then what does the 75 correspond with? The 9. So just the same thing we did. We just got to draw our own picture, that's all. All right, so what are we doing? Big over little or little over big? Or small over little? Or big over large? I'm just kidding. Which one do you want? Small over big. All right, small over big. So we're going small over big. So 6 in the small triangle corresponds with what? the X. And then 9 in the small triangle corresponds with a,
35.
yep. All right, so then we just do our cross products again. So we got 9 times X, that's 9X. And then we do 6 times 75,
50.
that's 450. And then we divide both sides by whatever number's in front of the variable,
X equals what? 50.
50. And our units are, yeah, if you look back, I didn't write them all on there because I didn't have enough room. But all of these measurements were in feet, okay? That was 75 feet, this was 6 feet, that was 9 feet, so it's in feet. So that's how tall the flagpole is. Okay? The flagpole is 50 feet tall. All right, let's keep going. We're almost there. Then there's a blank to fill in here. It says the flagpole is a scale of the man. That's what word is supposed to go in there. So SCALE. Which is really, it's the multiplier between the similar figures. It's really the scale factor. I'll write that here. And we already had a scale factor in that other problem, right? What was it? So many inches on the diagram were so many feet in the house. So that was the scale factor for that problem. All right, so last one. All right, let's see what we can do with this thing. So this says we got a rectangle with a width of 12 and a length of 3. So that's going to look something like, that's 3, that's 12. So this is 12 inches. This is 3 inches. All right. And then over here it says every dimension is multiplied by 1/3. So that's what it says right here. Well, you guys remember multiplying by 1/3 is the same thing as just dividing by 3, right? So really what this says right here is when you multiply by 1/3, that just means divide by 3. So divided by 3. And then this thing right here, this really is your scale factor right there. That's your scale factor. It's 1/3. Okay, so what would happen then if we divide this dimension by 3? What will we get?
4.
4. So we would get a smaller rectangle like, about like that. And then what would happen? That'd be 4, right?
Yeah.
And then what would happen if we divided this dimension by 3?
1.
Yeah, 3 divided by 3 would be 1. So we would have a small rectangle like that, right? That's supposed to be 1. And those would be similar, okay? They'd be the same shape but different size. Okay, so then what are the questions here we got to answer? It says, what is the scale factor? Well, I already told you what it is. What is it?
1/3.
It's 1/3, right? But they want the scale factor of the sides and the perimeters and the areas. All right, so let's look at this. So I think I can do this pretty quick for you guys. So we got to do this for the sides, right?
Well, the perimeter's 10, right?
Yep. So we got to do this for the sides. And we got to do this for the perimeters. And we've got to do this for the areas. Well, for the sides, we just match them up, right? So for the sides, you can see if you do 1 divided by 3, or if you do 4 divided by 12, you still get 1 over 3, right? And again, they're doing it little over big, right? So it would be little over big, it'd be 4 divided by 12, but that'd be the same thing as 1 divided by 3, right? So there's the scale factor for the sides. What about the perimeters? The perimeter, you add up the distance around, right?
So 10.
So the perimeter of the little one, let me put these on here first. So this side would also be 4, and that side would be 1, right? So what's the perimeter of that one?
10.
Yep. So it'd be 4 plus 1 plus 4 plus 1. So that is 10. And again, remember, we're doing this a little over big. And so then what's the perimeter of the big one? This would be a 12, and this would be a 3, right? So you would have 3 plus 12 plus 3 plus 12.
30.
Yep, that's 30. And what does that reduce to?
1/3.
That's also 1/3. So the scale factor of the sides was 1/3, and the scale factor of the perimeters is 1/3. Now what about the areas? How do you do the area of a rectangle?
Based on height or length times width.
Yep. So for a rectangle, the area is equal to the length times the width. So on this one, we just got to do 12 times 3, right?
36.
Yep. So our area would be 12 times 3 is 36. And then for the little one here, the area would be,
4.
that's hard to write in there. It'd be 4 times 1, right? Is 4. Well, let's do the ratio of the little over the big with the areas.
4 over 36.
Yep. So the little area would be 4 over the big area would be 36. That reduces to, divide them both by 4.
Yeah, hold on. Well, 1/9.
1/9. Which is the same thing as 1/3. Wait a minute. I don't know why I put a negative there. That's the same thing as 1/3 squared. I'll zoom in on that so you can see that. So the ratio of the, you know how areas in square units, right? Like a side length, that would be in, what are these in? Do they give us units on this?
Inches.
Inches. So the side length, that would be in inches. The perimeter, that's also a distance around it. That would also be in inches. But the areas would be in square inches, right?
That's what we're being keeping.
So look what happens. So the scale factor for the sides is 1/3. The scale factor for the perimeters is 1/3. But the scale factor for the areas is 1/3 squared. So it's actually 1/3 times 1/3, which should give you this 1/9 right here. Does that kind of make sense? So if you find the scale factor for the sides, you automatically know the scale factor for the perimeters is the same. And then you just square that number to find the